So design a milling fixture to cut a keyway on a given component. I think the second problem and the third problem both are quite similar to the first one. And though it doesn't need explanation, I just want to rush through. So we will see two examples. One is a keyway cutting. This is one example. Another example will be a slot to be produced in this area. So these two examples are quite similar. So I will start with the first one. So this is the component whose dimensions are given, and we are going to this depth of cut is 3 mm, width of cut is also 3 mm, similar to the first example. And in this case, to perform the given keyway cutting operation, a vertical milling machine is preferred. So this is the milling cutter. So a vertical milling machine is preferred. So we're going to go for a strap clamp. So this is a strap clamp which is going to hold and locate the fixture with respect to the cutting tool. In this case, a multi-point cutter, that is the milling cutter is used. So this is the fixture we are going to design. This is a very simple example, but still I just want to throw a bird's eye view. So selection of the fixture. So this is the that is the final fixture design. So we'll go for the locating methods. So we'll go for, in this case, we'll go for a step block. So this is the step block. So in this area, the component is going to rest. So this is how we are going to design. So this is the step block. This depends on the size of the workpiece also. The size of the workpiece also should be taken into account. So we can, this basically, this totally is based on assumption. So this is the height, this is the diameter D. So this D will be, that is the step block in which the step length equal to the diameter of the workpiece. So this is the dimension. This is how the step block has to be designed so that the component rests exactly on this area. Now the cutting force calculation, as I already told you, if it is specifically asked, you can go for the cutting force calculation. Or if it is a very small, that is the number of marks which are awarded are very, not more than 10 marks, then you can skip these steps. Directly you can go for selection of the clamping bolt. In case if it is a big question, then you have to go for this cutting force calculation. So similar to the previous example, 4.5 kf BD divided by CS. This can be assumed. Assume the feed as 75 mm per minute, and also the cutting speed as 75 meter per minute, or 75 into 10 power 3 mm per minute. Okay, so from this we will be able to calculate what is the force that is required. That is the cutting force. So the CS is 75 into 10 power 3 mm per minute, and this is K, we already know it is 8.5 kNm per mm square. So finally we will be able to find out what is the cutting force. See, the high carbon steel metal constant will always be constant. You can take it from the design data book, or you can remember it is 8.5 standard. The selection of the clamping bolt, since the clamping force must be greater than the cutting force. So we found that the clamping, there is a cutting force is 344.25 Newton. Usually the clamping force starts from 1000 Newton. So 1000 Newtons. So the diameter of the bolt, for this we have to go to design data book page number 5.49. One more thing I would like to tell you. See, this can also vary. See, this cutting force, this assume that is the feed that we are going to assume. If it is more, or if this varies, naturally the bolt that we are going to select will also vary. So we will be able to see this in the second example. I will tell you. For example, in the case of second example, see, they have used 100 mm per minute and 15 meter per minute. That is, the cutting speed is 15 meter per minute. In this case, it is 100 mm per minute. So naturally, what will happen? The cutting force will be more. So the cutting force is more. we can go for M24 bolt. This is the second example. Anyway, I will be coming back to this again. We'll go back to the first example. So since the cutting force which we have found out based on our assumption, that is 75 mm per minute divided by 75 meter per minute, it is only 344.25 Newton. So it starts with 1000 Newton. So for 1000 Newton of clamping force, we can go for M10 bolt. So the code design data book, page number 5.49, you will be able to tabulate, or you will be able to write down all these values. The entire value for M10 bolt can be written from page number 5.49. So this M10 bolt is going to clamp. So this is the strap clamp. I think we already know what a strap clamp is. This is the bolt that is going to firmly hold the workpiece. When you tighten this area, tighten the bolt, it is going to hold the strap clamp is going to completely hold and locate the workpiece with respect to the cutter. Okay. Now corresponding, so same, select M10 bolt, and this is the diagram you have to draw. This diagram can be drawn from the design data book. We can just tabulate all the values. So only some of the values are given here. This diagram is incomplete. You can write down all the values. Draw a neat diagram of the clamping bolt and even mention the various dimensions. And selection of the strap clamp. So to accommodate M10 bolt, we can go to page number, I think it is 5.94 in the design data book. In 5.94 you will be getting the strap clamp. So the strap clamp corresponding to the M10 that is bolt with M10 bolt, you can find out what are the values, the different dimensions of the of the strap clamp. And finally, design of fixture base plate is 50 mm into 50 mm. So this one. This is a very simple example. Similar to this, the earlier example which we used, this is also another slotting operation. So as you can see, the various dimensions are given. Similarly, there is the B is 5 mm, that is the width of cut is 5 mm, and depth of cut is also 5 mm. So in this case, we'll be using a double strap clamp fixture. So you will be using two strap clamps to hold and locate or clamp the workpiece. So we have to draw this. This is the final fixture. Then it has three locators. I think locator we have seen it in great detail while we design the jigs. So locators we know very clearly. So you can select a diameter of 16 mm, a round locator, page number 5.92, and you can note down all the values. So there will be three locators here. There is a rear end locator, and one more locator will also be on the other side. So three locators may be used. That is what is mentioned here. 16 mm round locator pin, 3 numbers are selected. So this is going to, as usual, as we already saw in the design of jigs. So these locators, the workpiece is going to rest on these locators. Again, these data can be tabulated used from the design data book, page number 5.92. So among 3 pins, 1 pin is placed on the left side of the workpiece. The remaining 2 pins are placed on the rear side of the workpiece. So in this diagram, these two locating pins may be seen. One more will be located on the other side. It is not visible. So this diagram has to be drawn. Again, the two strap clamps are selected. So cutting force, it is totally left to your assumption. So if you assume the feed is 100 mm per minute and the cutting speed is 15 meter per minute, then you will be having a large cutting force. So for larger cutting force, it is 6,375 Newton, and the clamping force should be always greater than the cutting force, so that the workpiece is held rigidly, right? So for 1000 newtons, in the earlier example, for 1000 newtons, we selected M10 bolt, right? Whereas in this case, For 6375 Newton, we can go for M24 bolt may be selected from the design data book, page number 5.49. Again, you have to note down all the values. Only some of the values are mentioned here. Go to page number 5.49, design data book. For M24 bolt, you have to draw the diagram. See, this diagram is not complete. You have to note down the complete diagram. That is, you have to draw this, and the complete diagram has to be drawn. Okay. And similar to the previous example, to accommodate M24 bolt in strap, select the strap with a slot dia of 28 mm. So go to design data book, page number 5.94. You will be able to see the strap clamp. So the corresponding values may be noted down. And finally, the dimension of the fixture base plate is also designed. There is 100 mm into 100 mm. Thus, we have designed two types of fixtures for two different components. Thanks for watching.